Hello everyone, this is Savannah Bekowski, Project Assistant at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Determining the Risk, Asset Management Risk Analysis Discussion and Available Tools. This session is one of several webinars conducted by the Environmental Finance Center Network for the Smart Management for Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local water systems achieve and maintain compliance with the Safe Drinking Water Act. Attendees will receive a certificate of attendance for viewing today's webinar. This webinar has not been submitted to licensing agencies for pre-approval of continuing education. Credits for continuing education credits. AWWA recommends that you check with your licensing agency to learn about its criteria, rules, and what you need to do in order to receive the credit for your attendance. It is your responsibility to verify this information with your licensing agency. If you do need assistance in applying for credit to your licensing agency, please contact Education Services at awwa.org. You will receive an email from AWWA 10 to 30 days after the webinar with a link to access your certificate. Here you can see the various centers that make up the Environmental Finance Center network. And you can see that the centers are spread all across the country from New York to Kansas to California. And here you can see the various areas of expertise that the EFCN focuses on. Workshops, trainings, and direct assistance are provided on fiscal planning and rate setting, asset management, energy use and efficiency, meeting regulatory compliance, multi-funding coordination, communication and decision-making, climate resilience, workforce development, financing, and managing small utilities in a drought. The EFCN also has a small systems blog. You can learn more about water finance and management through this blog. Blog posts features lessons learned from our training and technical assistance, descriptions of available tools, and small systems success stories. You can view this blog at efcnetwork.small_systems_blog. You will also have an opportunity at the end of this webinar to subscribe to the blog.
Savannah, I think you're still paused.
Oh, I'm sorry about that. Nope. All right. Now my webinar is locked. I'm so sorry about this.
Can you switch it to me? Oh, yes. There it goes.
All right. Well, at this point, before I turn the presentation over to our presenter, I have 2 quick polling questions for you. The first polling question is, what kind of water utility do you represent? Please take about 15 seconds to select one of the following: for-profit, municipality, not-for-profit, special purpose district, or you're not from a water or sewer utility. About 10 more seconds for voting. And getting ready to close the poll in 3, 2, 1. It seems that it's a pretty equal split between either not from a water or sewer utility or from a municipality. And the next polling question I have for you is, what size water or sewer system does your utility operate by number of people served? Please take a few seconds to answer from one of the following: very small, small, medium, large or very large, or not from a water or sewer utility. And about 10 more seconds for voting. And getting ready to close the poll in 3, 2, 1. And it seems that a majority of you are still not from a water or sewer utility, or you're large or very large. And at this point, I would like to turn the presentation over to our speaker for today, Dawn Nall, Program Manager at the Southwest Environmental Finance Center. Dawn, welcome and take it away.
Thank you. All right, so hopefully everyone can see my screen now and we're good to go. Thank you for being here today. I hope that it's as beautiful where you are as it is where I am today. So asset management has 5 core components, and we will focus today on the risk component, but I wanted to review all 5 core components before we dive into the meat of the risk analysis. So asset management helps you to determine how, where, and when to spend your money. Why should you be concerned or want to work with asset management? Well, first and foremost, it's a process that helps you run your systems simply in a better way. So the 5 core components are shown on the little graphic, and the first of those core components is the current state of the assets. The 5 core components that we use in our program are compatible with EPA's Advanced Asset Management Training and the International Asset Management approaches from Australia and New Zealand. Core component number 1 basically defines the current state of your assets. So to define those current states, you have to ask yourself a series of questions. You have to ask, what do we own? Where are the assets located? So do you have a good map? And a good map can vary. It can be based on paper. It can be based on a Google map. It can be based on a GIS mapping system. But are your assets shown on a map? What is the condition of the asset? And this can be a ranking, a grading, a description. But you want to know if the asset's in good condition or poor condition or somewhere in between. What's the remaining useful life of the asset? So how much longer is that asset going to be able to do what we need it to do? And then what is the replacement value of the asset? How much would it cost if you had to replace that asset today? And what is the energy use of the asset? Do you know the horsepower rating, or is the asset on a meter? Is it sub-metered? So answering these questions allows you to create an asset inventory. And your inventory can be stored in a variety of ways depending on your utility's needs. And that can range from pen and paper to a spreadsheet to a database to a purchase software. So as you're looking at beginning asset management, your utility should really consider how the inventory will be tracked based on the complexity of the utility. The second core component of asset management is level of service. So when we think about a water utility, oftentimes we don't think about it in the sense that water utilities are customer service businesses. But we are. We're in the business of serving customers. So defining what levels of service we aim to provide to our customers is really very important. So defining those levels of service that the utility plans to provide defines the goals of the utility and how we're going to operate. The goals allow you to communicate with your customer. Part of that communication should include the explanation that if the customer desires a higher level of service, typically the costs are going to be higher. The two are directly related. The level of service becomes the utility's roadmap, guiding you in your decision making. So as you set the goals and as you know what your targets are, when you're making decisions about where to spend your money, about how to operate your system, these goals are going to put you in the right direction. And when you're defining your level of service goals, we like to say that they should be SMART goals with the acronym of SMART. So specific, measurable, attainable, realistic, and time-bound. This will allow you to track your progress towards meeting those goals and to be able to report the progress that you're making to your decision makers, to your funders, to your customers. The Southwest EFC is in the process of developing a level of service document that includes guidelines, categories, and example goals. So if you are maybe struggling a little bit with determining what should or should not be included in your level of service, keep your eyes out for this helpful tool that's coming in the future. The third core component of asset management is criticality. So we know that not all assets are of equal importance to our utilities. Some are very important to operations and some are not. So for example, a small water or wastewater pipe that serves a few houses is probably not going to be as important to a utility as the single pump that supplies the entire water system. If the single pump would fail, the whole town would be out of water. So it's important for each utility to determine which of its assets are the most critical. When we talk about criticality, the two components that you want to look at are the likelihood that a given asset will fail and the consequence if the asset were to fail. So whenever we look at those two questions, we have several considerations that go into the determination. So for likelihood of failure, we would want to consider things like the condition of the asset, the age of the asset, repair history, historical knowledge, operation and maintenance history. And then for consequence of failure, we would want to consider the cost of the repair, the social impacts, costs associated with the failure, cost related to collateral damages, legal costs, environmental costs, reductions in level of service, and any other costs or impacts that are associated with the failure. You can reduce the consequences if you have redundancy in your system. If there are redundant assets, if one asset fails, another one's there to fill in for it, so to speak. So in this manner, the consequences are reduced because the failure of one of the assets won't cause a significant problem. And we'll be talking about the considerations that go into determining asset risk more here in just a few minutes. The fourth core component of asset management is lifecycle costing. So traditionally, whenever a utility looks to replace an asset, only the capital cost or the cost to purchase that asset is considered. But there are other costs that the asset will cause over the life cycle of that asset, and those costs typically aren't considered, but they include the cost to operate the asset, to maintain it, to repair it, if any specialized training is needed, so on and so forth. So analyzing life cycle costs helps you know when to continue with maintenance and repair efforts, and when to take the significant cost of investing in a new asset. So we don't want to spend too much by doing more of maintenance or replacement than we should. We want to try and balance those out. So a lot of times we're actually not doing maintenance at all. Our funding is limited and maintenance tends to get cut from the budget. If your utility is not funding any type of maintenance, you've put yourself into a completely reactive mode waiting for something to break. And it's been shown that if you're operating in reactive mode, you're actually operating in a way that's costing you 3 to 4 times more than if you were performing maintenance. So it's possible to justify putting maintenance back into your budget. And as you go through asset management and you look at the costs, it will become very apparent that investing in maintenance is a wise decision. It's not possible to have a system that's 100% planned maintenance and no reactive, as ideal as that would be, but a good goal is to be about 70% proactive and about 30% reactive. So I have a question I'd like you to consider. If an airplane was maintained the way you maintain your water facility, would you fly in it? If you answer no, think about why that's the case. Maybe we're not doing enough maintenance. The final core component of asset management is long-term funding. Once you've determined what assets need regular maintenance and replacement, you have to determine how you're going to pay for those items over the long term. You have to determine your funding needs for your day-to-day expenses, for your operations and maintenance, and for your long-term capital expenses for your large replacements. And then you have to determine where that money is going to come from. So the money can either come from internal sources, your rates and fees that you charge to your customers, or from external sources, and those would come in the form of grants or loans. So the EFCN has several funding tools and resources available on our website, and the web address is shown at the bottom of every slide. These include funding tables that list funders for water utilities by state, and then there are several other tools and guideline documents. There's the Financial Health Checkup for Water Utilities tool. There's a Plan to Pay Scenarios to Fund Your CIP tool, Water and Wastewater Rates Analysis Model tool, and Designing Rate Structures that Support Your Objectives, which is a guidance document. And there are several other references and resources available on the website specifically about funding. So now that we've taken a kind of a quick overview of the 5 core components of asset management, we'll get into our risk analysis discussion. So you have an inventory of assets. You have any number of assets that you have to take care of to keep your water system functioning. You have a limited budget, and you have limited resources to deal with those assets. So how do you pick which activities you should do first? How do you prioritize? You have to determine which of the assets are most critical. But how do you go about doing that? You use your risk analysis. Each utility should determine what your critical assets are. So when you're doing that, you have to ask yourself those 2 questions. How likely is it that the asset will fail? And what is the consequence if the asset does fail? So if you look at the 2 pictures that are shown here, you can pretty easily start to answer those questions for the asset shown. So for the first picture of the fire hydrant being opened, if you asked, how likely is it that that hydrant is going to fail? You would pretty quickly have an answer, definitely, or it already is failing, or very likely to fail. And then if you look at the second picture, you can see that there's a truck in a sinkhole caused by a leaking water line. So if you ask the question, what are the consequences of that water line failing? You'd probably have a pretty quick answer for it too. You would want to know about the financial cost to the utility, the social cost to the utility, and the environmental cost. All of those would be important to consider. There are different ways that an asset can fail, so we want to think about each of those categories when we complete our risk analysis. So we'll look at the 4 different areas. The mortality failure is probably the most common type, or what comes to mind most often. Things like leaks, stuck valves. This is where something physical happens to the asset and it fails because of a physical problem. So I've got some pictures here that are pretty extreme cases of mortality failures, but there are many other types of mortality failures that we come across. And then there's level of service failures. This would be related to a change in regulations and customer demands or customers' desires. So in this example, the customers want fire flow, but they currently have 4-inch pipe, and you would need to put in 6-inch pipe. So you may be replacing perfectly good pipe, but it's failed because it cannot meet the level of service demands. So you would be replacing it with 6-inch pipe or larger. Or for another example, a well has arsenic and it cannot meet the regulations, so you decide to abandon that well for another well. So even though this well is capable of producing water and meeting flow demands, it does not meet regulations. So you abandon it for another well with lower levels. These are level of service failures. Capacity is a third type of failure. So this is where an asset's not able to deliver something like the flow that you want. The pipe could be in decent shape, but not delivering the flow that you need. So that's a capacity failure. And then financial inefficiencies. This is where we're spending too much money to continue to operate and maintain the asset. It would be cheaper to go ahead and replace it. So typically it's cheaper to do maintenance than replacement, but there does become a point in time where that's no longer true. So if you've got a pipe that's almost all clamped, it's probably time to replace that pipe. Or if you have a pump that's been band-aided more times than you can count, it may be time to go ahead and replace it. So this is cases where we're spending so much on operation and maintenance, it's time to replace the asset. Then when we look at the question of what are the consequences if the asset fails, we want to consider the triple bottom line. We want to ask ourselves, what are the financial consequences, the environmental consequences, and the social consequences. And these can be quantitative, qualitative, or both. So if we're looking at the financial consequences, we would want to think about how much is it going to cost us to repair or replace the asset? How much does it cost? How much damage was there to other assets, and what's it going to cost us to repair or replace those? Are there legal fees? Are there any costs associated with having to pay customers or businesses for damage? When we look at the environmental consequences, we want to think about violations, fines, any loss of habitat, any loss of animal life, any impacts to endangered species. And then when we consider the social aspects, if there's any loss of respect or confidence in the utility, the length of time that people were without service, reduction in business income due to the lack of service or repair work blocking the businesses. We want to think about safety and health concerns for the workers or the general public, any inconvenience due to blocked streets, and any reduction in level of service. Once we a failure and the consequence of failure, we can rank those and we can calculate the risk. So you can use scores or rankings to calculate the risk. Probability of failure and consequence of failure could be given a ranking of 1 to 5 or 1 to 10, with 1 being very low and 5 being very high. And then you can multiply those scores together and come up with your risk ranking. But there are ways that utilities can reduce that risk for each asset. So if you see the list here, by performing maintenance on the asset, you're extending its life and therefore decreasing the probability of failure. If you have parts on hand, you can decrease your repair times and increase customer confidence. Both of these allow you to decrease the scores for consequence of failure. For assets that are absolutely necessary to the performance of the utility, you can replace them before their expected useful life is up to make sure that they never actually reach failure. If this is planned and budgeted for, it decreases the probability of failure. If the system has redundancy, one well can meet the demand, but 2 wells are available, this decreases the consequence of failure. If an asset requires specific knowledge to repair it or replace it or operate it, having a person on staff with that specialized training can decrease your response times and your costs, and that could potentially decrease both probability of failure and consequence of failure. Monitoring asset performance can give you greater knowledge of the asset's condition, its remaining useful life, and other aspects about the asset. So that additional knowledge could decrease both probability of failure and consequence of failure. So if you're using any of these tools, you should take them into consideration when you're calculating your risk. So if you have redundancy in the system, you can take that into account by adding a risk reduction factor into that calculation. This is where you would want to include a number between 0 and 1, with the lowest number closest to 0, meaning the redundancy in the system reduces the risk significantly. Or if you prefer, you can leave the reduction factor out of the calculation and you can just reduce the ranking for probability of failure or consequence of failure accordingly. And that's perfectly acceptable, but it doesn't track for you why the scores are lowered. So if you think next year when you come back and you take a look at this again, you may not remember why the score is what it is. Make sure that you have a way to record that information in a comments category, or go ahead and use that reduction factor so you know whenever you've taken that into consideration. Once you've calculated the risk, you can add that information to a graph, and it gives you a thorough visual representation of your asset risk. So if you completed a risk analysis for your wells and the results look like this, what does it tell you? What do you gain by having this information? Well, it helps guide your decision making. The information that you've collected and summarized about the assets is now really useful. It's right here in this visual representation. So when the graph, how much more knowledge do you have about the wells than if I started just telling you the age of each of the wells, the condition, the risk that it carries, all of that information that we've tracked so far becomes very clear in this one image. So you can use this graph to guide your decision making in many areas. So risk analysis should be the guiding factor on where to spend routine, preventative, predictive maintenance you should be doing each asset. Low-risk assets should probably receive some routine maintenance, but not much preventative and probably not any predictive maintenance. On your moderate risk assets, you probably want to do routine maintenance and preventative maintenance. And on your high-risk assets, you would probably want to do all three types of maintenance because you want to do whatever you can to prevent failures on those high-risk assets. If you think of expense, the cheapest maintenance is routine, the preventative is next, and predictive is usually way more expensive. So it only makes sense to do the most expensive maintenance on the highest risk assets. In the same way, the risk analysis will guide your decisions when setting your budget, looking at your long-term capital improvement plan, and determining when and how much to adjust your rates. And how to optimize your system operations. So things like frequency and location of line flushing. Maybe before asset management, you were flushing once a year at the ends of the lines. But when you get into asset management, it looks like that there would be benefit to rotate around the locations and maybe to open a hydrant closer to the middle of the system and not at the end of the line mid-year, and then flush at the end of the line at the end of the year, something like that. So you start to learn more about how to best operate your system. Or it could be something about your valve exercising program schedule, or any other operational decisions that we make can be impacted by our risk analysis. So what types of tools are out there to help you when you're doing your risk analysis? There are a couple that I want to talk to you about today. So the EFC has developed the EMCAN work guide, which is a manual that was sponsored by the state of Kansas. And the manual is available online, and it provides many resources in the book and in the appendices. There are very specific documents and spreadsheets that you can download. There are video clips in this guidebook from water and wastewater utilities around the U.S. discussing what they're doing with asset management. So if you're maybe stuck on what to do with the next kind of step forward, you can go to the manual and watch some of the videos about what others have done. The manual is also available on DVD and in hard copy form. If you are interested in those, you can let us know, and we ask that you pay the shipping costs. In the appendix, you can find tools like this one that lets you complete your risk analysis. So this table, you would rank your assets' probability of failure in the blue box at the bottom. So you would circle one of those scores, and then you would rate the consequence of failure in the blue box on the vertical. So if you gave probability of failure a 3 and consequence of failure a 4, you would come out to the white box and your risk score would be a 12. And you can track which asset you've done the risk analysis for and the date that it was completed. You can make notes on these pages. You can add information All of this is available to you to use at your utility and to add to or take away from as you see necessary. Also in the appendices, there's a graph that can be used to place the scores for the various asset categories. So each of these tools is there for you to use as you see fit. There are tools for all of the core components of asset management in the guidebook. So if you download the manual, you get all of those tools, not just the risk analysis tools. Also, we've developed a new tool and updated the inventory reference guide. We've added to it. So we have a reference guide for asset management, inventory, and risk analysis. So we want to help you get started when you're looking at completing an inventory and also when you're completing your risk analysis. So there are several places that you need to go to kind of look for information about an asset, different types of information you want to collect. So when you look at this tool, the first table on each page will guide you in the type of information that you want to collect for the asset category listed. And then the second table on each page will provide you guidance on the factors you should take into consideration when you're evaluating your probability that the asset will fail and the consequence if that asset were to fail. So the lists are meant to get you started. They're not exclusive. There's likely other things that you will come up with that you want to add to your system. So for example, just recently, I'm working with a system on completing a risk analysis, and one of the factors that they wanted to consider for pipe was if the road that was above the pipe was on the resurfacing schedule in the next 2 years. So that's a factor they wanted to consider that's not on my list. So I'm sure that there will be things that you come up with, but this is a way to get you started, get you thinking about things to consider as you're ranking the probability and consequence of failure. So this is an example of what's included in that guide for determining the risk for hydrants. So when you're ranking the probability of failure, the probability that that hydrant will fail, you want to take into consideration the age of the hydrant. What condition is the hydrant in? How often is it opened? Is any maintenance been done to this hydrant? Is it on the right size pipe? Can it actually handle fire flow? Do you have the tools that you need to open the hydrant? Sometimes our hydrants are older than we are, and maybe somewhere along the road a tool that we need has been misplaced. So do we have the tools that we need? And then when we're looking at consequence, if the asset does fail, so if that hydrant fails in any way, what are the consequences? So things that we want to think about include, remember that triple bottom line, financial, social, and environmental. Would there be damage to nearby structures if the hydrant failed? Would you be able to flush the system if it failed? Would you still be able to fight a fire if the hydrant failed? So that would be redundancy. Would you be able to maintain your level of service if the hydrant failed? And then would there be any environmental consequences if the hydrant failed? So this is just an example of what's in the guidebook to kind of get you thinking about things to take into consideration in the scoring, ranking process of probability of failure, consequence of failure. This is what the tables look like in the guidebook or in the guide document so that you kind of know what to expect. So it tells you what the category is. So at the top here you can see that this is for pipe, and it tells you a little bit more about what types of pipe are included in this table. So you can find these tools on EFC Network's website in the resource library. So the website is for the resource library is right here at the top of the screen. When you get to the website, this is what it's going to look like. And there's going to be a series of questions. What does your system need help with? So there are tools available for all of the topics that we talked about at the beginning of the webinar that we cover under the Small Systems, Smart Management for Small Systems program. So there's many different resources available. If you want to just go directly to the inventory reference guide, it's available at this web address at the bottom of the screen. So I'll leave those up there for just a minute. At this time, if you've got questions, feel free to type them in. I'd be happy to do my best to answer your questions. And I wanted to thank you for your time today. I also wanted to mention that if you need assistance working on asset management, whether it's risk analysis or components, or any of the other topics that we mentioned that are listed on our website, there's a form that you can fill out to request one-on-one technical assistance. Once you fill it out and submit it, one of the EFC network colleagues will be in touch with you. So we have that available at no cost to small water systems. Are there any questions at this time?
Hi, Dawn. We do have a question. It came in through the questions box, and it asks, you stated that reactive maintenance costs 3 to 4 times preventative maintenance costs. Do you have studies or specifics to justify this statement? Can you provide those materials to us for a presentation to governing bodies?
There have been studies completed. I don't have, but if you email me at the email address that's on your screen so that I can respond to you, I would be happy to get you some of that information so that we can help convince your governing bodies that you should be doing maintenance.
Great, thank you. The next question is, do you provide assistance to wastewater systems?
We can assist wastewater systems, but not under this particular project and funding. The different EFCs have different funding sources, and so it depends on, it kind of depends on what your needs are and where you're located, and so this particular funding from EPA is specific to small, serving fewer than 10,000 water systems. But we definitely have helped wastewater systems in the past under other mechanisms of funding. So again, if you want to email me at the email address on the screen and kind of let me know a little bit more, we will see what we can do.
And a question did just come through if you recommend any other software for small systems other than CUPSS.
Okay, so the checkup program for small systems is a software that's available for free from EPA, that's CUPS, and there are other softwares out there. As part of the guidebook, the EMCAN work manual, there are spreadsheets available for doing inventory. There is a database that's based on Microsoft's Access program that's included and is free. So if you have someone at your utility that is familiar with Microsoft Access, there's a shell there that lets you track your inventory and your risk and can be modified in any way that you see fit. There are other softwares out there. There are more and more app-based softwares being developed because a lot of what we do with asset management is done in the field with our phone in hand. There are cloud-based softwares. There is a plethora of softwares out there. And I do not have any that I recommend generically. And the reason is that our systems are so different in size and capability, and if we're technologically advanced or we're technologically challenged. If I said this is the software that everyone should use, I would be immediately wrong. So what we'd like to do is encourage you to take a look at where your utility is at. How many assets are you tracking? How many employees would need access to that software? Would it be something that you want to be able to access from home, from the field, or only at one computer in one office with one password? And consider what you want that software to be able to do. Do you want it to be able to connect to your billing software? Do you want it to be able to connect to your maintenance software? Do you want it to be your maintenance software? So whenever you're looking at the options that are out there, go into it knowing what you want to get out of it. Because there are lots out there, and you can pay for many, many bells and whistles. And if you will use all the bells and whistles, then it's probably worth it to pay for them. But if you're not going to use the bells and whistles, then don't pay for them.
And the next question is, how important is having a CMMS in place?
Again, I think that depends on the size of the utility. So a CMMS is a computerized maintenance management system. So your CMMS can be tied to your asset management. It should be tied to your asset management planning. If you don't currently have a CMMS software and you're starting or are a fair ways down the road of asset management, again, I think that depending on your system's size and how comfortable you are with technology, it could benefit you to have a CMMS, or it could just be very frustrating that you spent money on something that you can't get to do what you want to do. I have worked with systems that have been very successful with pen and paper, some good as-built record drawings that they pen to the wall, and they use different color markers to show maintenance, and they use push pens to show hydrants, and their inventory is in a notebook with pen and paper, and they're very successful because it's a small system with a couple of people. That's about the level of technology that they need. So I would say for them, a CMMS would probably not be beneficial. And then I've worked with other systems where having a CMMS tied to their asset management planning, or their CMMS software is also their asset management software, is very beneficial. They're larger, they have multiple operators, maybe they work shifts. It helps improve communications. It helps people know what their responsibilities are when they walk in the door that day. So again, it's dependent upon your utility and what your needs are.
Great. And the next question is, do you provide assistance to wastewater systems?
Again, under this specific funding, we cannot provide assistance to just a wastewater system. This funding is specific for small, serving fewer than 10,000 drinking water systems. But if you want to get in touch with me and see what your issues are, and maybe if there is a way that we can work with you under different funding or different topic area, we can see what we can do with you. I won't say absolutely not, but I won't say that we can work with you at no cost either. So we have to kind of see what the scope of work is.
Great. And the next question is there any guide or document on how to assess conditions of assets besides visual inspections?
In the EMCAN work, in the appendix, there's a table that talks about different ways that you can assess condition for different types of assets. Obviously, a lot of our assets in water utilities are buried or are difficult to visually inspect. So there are different methods for different types of assets listed in the guidebook, and that's based on the International Asset Management Manual.
And this is a great follow-up question. Is the EMCAN work manual available for digital download?
It absolutely is. On the EFC Network website or on the Southwest EFC's website, you can download it. There's a username and password, and it's provided for you at the EFC Network's website or Southwest EFC's website. So you can go to our website, and you are free to download it and use it and share it and let other people know about it. We're happy to have it out there.
And now, have you ever heard of the ESRI? And does this help with the maintenance planning and tracking?
I have, and it can help, especially if you're looking at energy management and asset management, and the two definitely go hand in hand. The EMCAN work manual is focused on both asset management and energy management. So if you are looking at energy use of your assets along with their condition and their risk, you can look at how much energy they're currently using. If you replace the asset, could you replace it with something more energy efficient? So there's information about both in the manual, and there are other resources on our website about energy management, specifically for energy management. So I think that that's the ESRI you're speaking of. I hope it is, but if not, you can type in and let me know if it's something different.
Great. And regarding risk versus cost, do most states fine utilities when a water main breaks that could create a fish kill?
I do not know the specifics to that answer for each state. I apologize, but I don't know all of the environmental rules for every state. I know that most states have a discharge for wastewater systems about not discharging chlorinated water into a body of, I mean, it can be just about any body of water, a stream, a river, a creek, anywhere that there could be fish. And I would assume that that carries over for drinking water, but I can't tell you if they fine you, or I apologize. I just don't know the answer.
No worries at all. You've been answering a ton of questions. And at this time, that is all the questions that I have received through our question log box. And quickly before we wrap up, I will be sending out 2 final polling questions. And the first polling question is, if you are a small water system of 10,000 or fewer people served, would you be interested in receiving in-depth technical assistance? If you are unsure about technical assistance or did not have the opportunity to submit your polling answer, please review the technical assistance form on our efcnetwork.org website. And getting ready to close the poll in 3, 2, 1. And the last poll question is if you would like to subscribe to the Environmental Finance Center blog. And again, if you want to sign up for the blog but do not have the opportunity to submit your polling answer right now, you can sign up for the blog on our efcnetwork.org website. And getting ready to close the poll in 3, 2, 1. Thank you for your submissions. And at this point as well, I will be sending out a link through the chat box for a survey for today's webinar. If you have a chance, please take some time to tell us your thoughts on the webinar today. You will also receive a follow-up email tomorrow with the survey link, as well as the links to the slide and recording. And thank you, Dawn, for the thorough and informative presentation today. It was extremely informative.
Thank you, and thank everybody for your time and attendance. We appreciate it.
Have a great day, everyone.